Section 7.6, complex rational expressions. When we have a complex rational expression, what we're talking about is an expression that is made up of fractions containing fractions. So it's a fraction where the numerator and or denominator is also a fraction. To simplify, there are two methods. Method 1, what you're going to do is you're going to work the numerator and denominator separately. And what that involves is getting common denominators and adding or subtracting wherever you can. Then, when you get all of that done, you're going to change the problem to multiply by the reciprocal and simplify it. Method 2. The first step is going to be to find the LCD of all the fractions within the problem. Then you're going to multiply every term in the problem by the LCD and simplify. So how do I know when to use which method? Well, it's really going to be up to you, but there are times when one method would seem to be simpler than the other. For example, on letter A, I would choose method 1, and the reason I would choose method 1 is that step 1 is already done, meaning there is no addition or subtraction that you could possibly do. So if I look over to part B, this numerator has two separate fractions that I would have to add together. Over here on letter A, I don't have any separate fractions that could be added together. So I don't need to do anything for step 1, which is why I'm choosing method 1, because I get to jump right to step 2. Step 2 is to change this to multiply by the reciprocal, which should be a familiar process from section 7.2. Now I'm going to factor squares pattern, cancel the x plus 3's, reduce the 4 and the 8, and what I have left is x minus 3 over 2. Part B. Using method 1 or method 2, this one, you could go either way. So I'm going to show you this one with method 1. Because while step 1's not already done, I pointed that out earlier, it is halfway done, because the denominator does not have any separate fractions I need to combine. And so what I would do is I would work the numerator. Working the numerator, my LCD is 3y. So I'm going to multiply the first fraction by y and the second fraction by 3 to get y plus 3 over 3y. So this is my numerator, y plus 3 over 3y, multiplied by the reciprocal of the denominator. The y plus 3's cancel, and I have 4 over 3y. These next two problems are ones I would definitely opt for option 2, or method 2. All right. Because I have separate fractions on both the numerator and the denominator, so what I'm going to do for method 2 is I'm going to look at all of my individual denominators, a squared, a to the third, a, and I'm going to determine the LCD. Remember with variables, the LCD is the largest of the exponents, so it's a to the third. And then what I'm going to do is I'm going to multiply each of my individual fractions by a to the third. So I have 2 over a squared, multiply it by a to the third. 3 over a, multiply it by a to the third. Every part of my original problem, I am multiplying by a to the third. If it helps to put a 1 under them, you can. And then what's going to happen is all of my fractions are going to do a lot of canceling. So a to the third over a squared, that's just a. A to the third over a is a squared. Those cancel. And here I have 4a squared. Factor, GCF. This one's a squares pattern. But nothing matches, there's no common factor anywhere, so I'm just going to call that done. Letter D, using method 2. My denominators, I have x plus 3, 1, 1, and x plus 3. So the LCD, the common denominator, is just x plus 3. So I'm going to multiply multiply each part of my original problem times x plus 3. And then what do I get? I get a lot of canceling. Distributing the 1, distributing the x, combining like terms, and then I'm going to factor cancel, cancel, and I get 1 over x minus 1.